Okay, we are now recording. So, Ahmed, you might want to turn off your camera unless you want us to see that dark room, but whatever. Okay, so for those of you who can't attend, let me just a couple of things. Number one, it's really hard for me to follow the, I'm going to turn on the light here. It's really hard for me to follow the chat. So if you have something to say, please speak up. Because if you type something in the chat, I probably won't see it. Trying to make that as straight as possible, but it doesn't work with my setup here. And all right, so we're going to be talking about 6.1, which is matrices. Okay. Now, this is really kind of a continuation of chapter 5. What I'd like to do is I'd like to show you if we had a system of equations. Let's say that I had, this is really far away. All right, let's say that I had an equation 2x minus y equals 5. And I had another equation, x plus 4y equals 7. Okay? Now, one way we could write this, what we could do is we could write what we call the augmented matrix. The idea with the augmented matrix is I'm going to ignore the variables here. So I'm just going to write the coefficients. So this first line becomes 2, -1, and 5. The second line becomes 1, 4, and 7. Okay, and then we will put that in with a straight line around each side, or sometimes you'll see it with a little bracket. That is the augmented matrix. So if that were a test question, you'd probably be very happy about that, right? Okay. Now the idea here with an augmented matrix, the regular system of linear equations and the augmented matrices work the same way. Okay. Let's go back to here because you guys are familiar with, if I had 2 equations and 2 unknowns, how would I solve this? Using elimination. Actually, let's use elimination. I could either eliminate the x's or the y's. How would I do that?
-2 into the bottom equation.
Okay, so I could multiply the bottom equation by -2. And so if I rewrite the top equation, this becomes 2x minus y equals 5. And then the bottom equation becomes -2x minus 8y equals -14. Correct?
Yes.
Okay. So what I could do here with the augmented matrix is I could take -2 times row 2 and do the same thing. So I'm just going to rewrite the top equation, 2, -1, and 5. And then -2, -8, and -14. Okay. So the the matrix works the same way as we've done with elimination before. Okay. So in this case, we're going to eliminate the x's. -1y minus 8y is -9y equals 5 minus 14 is -9. Does that make sense? Okay. Now, if I do that with the matrices, okay, if I take row 1 plus row 2, and I put the result in row 2, okay, so if I got 2, so I'm going to rewrite the top row because that's not changing. 2, -1, 5. And then we're going to add these together. 2 minus 2 is 0. -1 minus 8 is -9. And 5 minus 14 is -9. Okay, so essentially we've done all the same things. Okay, now over here we're going to divide by -9, and we're going to get y equals 1. Okay, now we can also do -1/9 times row 2 equals row 2, okay? So basically, if I divide this by 9, I'm going to get, the top row is not going to change, 2, -1, 5, and 0, 1, and 1. Okay, so now we can take this bottom row and we can say that y equals 1, just like we said y equals 1 over here. Okay? Now, normally we would take this back and we're going to substitute back into either equation. We'll substitute it into the top equation here, and that's going to give me 2x minus 1 equals 5. I'm going to add 1, and I'm going to get, now I'm running out of room, 2x equals 6, so x is going to equal 3. Okay, we'll do the same thing here. We can plug the y into here, and I'm going to get 2x minus 1 times 1 equals 5. I'll add my 1, 2x equals 6, and so therefore x equals 3. Okay, so the idea here is with the matrices, you can do the same thing that you would do with elimination over here. Does that make sense?
Yes.
Okay, thanks. It's glad to have somebody answer. Okay, so let's do another example.
Hey, Professor.
Yes, go ahead.
So I assume we're going to be using this more extensively, but is this kind of like a preferable option to doing it over elimination, or it seems like it's kind of the same thing, or it's doing the same thing?
It is doing the same thing.
Gotcha. So it's just like another substitution or substitute for the method.
It's just another way to do this. Now here you may be asking yourselves, why do I care about matrices? And the fact of the matter is, computers can handle this really well, and so a lot of times you don't just have 2 equations and 2 unknowns. 2 equations, 2 unknowns, it's probably easier to do eliminations. But if you have 10 equations and 10 unknowns, it's much easier to program a computer how to solve that with the matrix method than any other method. So this actually, so the idea here is this leads to what we're gonna call Row-Echelon form. Okay, and the idea with Row-Echelon form, we won't get more than a 3x3 matrix, but the idea here is we're going to want to try to get 1s on the diagonals and then 0s here. Now you could have any number here, and then the idea here is, I'm going to put a little dotted line here. If you had 3, 2, and 1, this here, this last column, would be what you would call, here I'll put this as matrix form, this last column we would call the solution set. And the nice thing is when you get down to the bottom row, you get z equals 1 in this case, and then you can back substitute here and then there, and then it's really easy to find the equations. Okay, does that make sense? And so we could do another 2x2, but let's go to a 3x3 this time. So I'm going to have you guys help me, and we'll do this. Okay. So if I have, let's go with x minus y equals, sorry, plus 3z equals 4, and x plus 2y minus 2z equals 10, and 3x minus y plus 5z equals 14. Now, by the way, I guess I should mention, and this is getting to be an old movie now, but do you guys remember the movie Matrix?
Yep.
Okay, Matrix is all about virtual reality. That's what they're doing, is they're turning all these equations into a matrix and putting you in the matrix so that you live a virtual reality, not a real reality. So So anyway, all right. So how would I convert this 3 by, well, so this is 3 rows. This is a 3 by 4 matrix. Can you write the augmented matrix?
So would it be like the first row 1, -1, 3, and 4?
Okay.
The second row will be 1, 2, -2, and 10.
And the third row?
3, -1, 5, and 14.
Okay. All right. So well done. Now the idea with when we start, especially when we start doing a 3 by 3 matrix, one of the things I think that students hate about this method is it takes up a lot of paper.
Yeah.
I can't do much about that, but at any rate, so the idea here is we want to get it in row echelon form. Okay, we want ones on the diagonals and we want zeros underneath the ones, basically. And then you can use reverse substitution to find the other values. So the nice thing here is I have a 1 in the top row. Now, if I didn't, and if I had a 1 here, we could actually flip those rows. That wouldn't do anything. Okay. Now, the idea here is I'm going to use row operations. And so typically, the way you want to do this, you want to get a 1 in the first spot, and then you want to turn these into zeros. So you're going to kind of work in columns. We're going to eliminate the x's, okay? So hopefully you can see that if I take row 1 and if I subtract row 2, and I put the result in row 2, that will put a 0 right here. Does that make sense? Okay. Say that again.
No, sorry, that was my kid.
Oh, okay. I thought that was a question. All right, so I'm just going to rewrite. Normally I'd go down the page, but I think it's easier for you guys to see if I go to the right here. Okay, so I'm just going to rewrite the top row. 1, -1, 3, and 4. And now I'm going to take row 1 and I'm going to subtract row 2. So 1 minus 1 is 0. -1 minus 2 is -3. 3 minus -2 is 5. And 4 minus 10 is -6. Okay, so I just did row 1 minus row 2. Okay, now I want to get a 0 here. And so what can I do with row 1 in order to turn that 3 into a 0?
Could you multiply it by -3?
That's perfect. And so, yes, so we're going to take -3 times row 1, and we're going to add it to row 3, and we're going to put the result in row 3, okay? So I'm going to put a -3 here just to help myself. So -3 plus 3 is 0. +3 minus 1 is +2. -9 plus 5 is -4. And -12 plus 14 is 2. Okay. All right, so I've eliminated the x's. Now, according to row echelon form, I want to put a 1 in that middle square. Okay. Now, one way I could do that is I could divide by -3, and that would turn it into 1. But if I do that, that's going to turn this into a fraction. And I know that most of you think that fraction is an F word. So here's what I'm going to do. I'm going to swap row 2 and row 3, and then I'm going to divide the new row 2 by 2. Because you can see if I swap these two rows and if I put this here, if I divide by 2, that's going to be a 1 and I won't have to deal any fractions. Does that make sense? Okay.
Yeah.
So I'm going to divide by 2 and then I'm going to move that row here and then I'm going to move this row down here. Okay. So essentially, okay, so the top row is going to stay the same. 1, -1, 3, and 4. Okay. And then this becomes 0, 1, -2, and 1. Okay, so I've just divided that row by 2 and I've put it here. Now I'm going to just rewrite row 2 in row 3 spot, 0, -3, 5, and -6. Okay, so that's what I've done. Okay, now I need to turn this -3 into a 0, and I'm going to use row 2 to do that. So how can I use row 2 to turn that -3 into a 0?
Multiply it by 3.
Multiply it by 3. So essentially what I'm going to do is I'm going to take 3 times row 2, and I'm going to add it to row 3. I'm going to put the result in row 3. Okay, so the top row is going to stay the same. Okay, I'm going to get 1, -1, 3, and 4. And then the middle row is going to stay the same as well. 0, 1, -2, and 1. And then the bottom row, okay, so that's where this comes in. So 3 times 0 is 0, plus 0, 0. So 3 minus 3 is 0. 3 times -2 is -6, plus 5 is -1. And then 3 minus 6 is -3. Okay. Now, it's really easy to see. This is almost row-echelon form, right? As we see here. I just need this to be a positive 1. What's the easiest way to turn that into positive 1?
Multiply it by -1.
Multiply by -1, so that becomes a positive 1 and a positive 3. So this bottom row becomes the equation z equals, sorry, I'm off the page, aren't I? Z equals 3, right? Do you see that? Z equals 3. This is your X column, this is your Y column, this is your Z column, this is your solution set. Okay? So if Z equals 3, now I can do some back substitution. I can plug it into this second equation, and I'm going to get what?
Wait. How was that again?
I'm going to plug this Z into this middle equation here.
Okay.
And I want to solve for Y. So this represents 0x, right? Plus so Y minus 2 times 3 equals this number here, which is 1. Does that make sense?
Yep.
Okay. So this is -6, so I'm going to add 6. I'm going to get Y equals 7. And now I've got my Z, I've got my Y. I'm going to plug it now into this first equation, and that's going to be X minus Y, which is 7, plus 3 times 3 equals 4. So -7 plus 9 is +2. So if I subtract 2, I'm going to get X equals 2. Does that make sense?
Yep.
Okay, so I've just done, this is basically elimination, just done with matrices. Okay. Now, couple of things to remember. I was worried that we were going to run out of time because this is kind of a long section.
How did you solve for Z? Like, how'd you get 3?
Okay, so when I went through all of these steps here, I was trying to get it in row echelon form. row-echelon form, okay? Which means I want ones on the diagonals and then zeros underneath the ones, okay? So when I went through all of these steps, I got ones on the diagonals and I got zeros underneath. So this is row-echelon form, okay? Now this equation here, because I've eliminated the x, I've eliminated the y's, I've only got a z, so this is 1z equals 3. So basically I pulled out from this bottom equation here, this bottom equation now represents z equals 3. Does that make sense?
Yeah.
Okay. And so now you can just back substitute, because this represents y minus 2z equals 1, and this represents x minus y plus 3z equals 4. Okay? All right. Now, let me just, I want to show you guys a couple of things that you'll come across. So the idea here is row-echelon form. This is our big deal. We want ones on the diagonal, zeros underneath, and then we can always use back substitution. This is a z equals 1. This would be y plus something equals 2, and x plus something equals 3. Now, we do have, I just want to show you a couple of situations that could arise when you're doing this, okay? Let's say that you're working out a system of equations. You're trying to get it in row-echelon form, so you get ones on your diagonals, except for, in this case, what if you got 0, 0, 0, and 4? So these, let's pretend that's a 0, and this is whatever it is. And these are whatever these are. Okay? Now let's look at this bottom row. Do you see a problem with the bottom row? What does the bottom row represent if this is the x, the y, the z, and the solution set?
No solution.
Yes. So this represents 0 equals 4, right? Which is not true. So we would say, instead of saying no solution, I'd prefer if you called it inconsistent. Okay? So if you're going along and you get 0 equals 4, rather than saying no solution, you would say it was inconsistent. Now, the other thing that can happen is, let's say you've got your reduced row-echelon form, and you get 0, 0, 0, and 0. Okay, these can, we'll leave that as 0. These can represent whatever numbers these are. Okay. Now this would represent what? 0 equals 0, which is a true statement, correct? Okay. So essentially, in this case, it's not inconsistent. This is what we would call a dependent solution set. Basically, what would happen, the idea, usually when this happens, basically you have two lines that are the same. So maybe you'll have 2x plus y equals 3, and you'll have 2x plus y equals 3. You can see that those, or rather, maybe you'll have 6x plus 3y equals 9, okay? These are basically, this equation here and this equation here, these are basically the same equation, correct? This one's just multiplied by 3. And so essentially what's happening is you've got the same line twice, and that's how you'll end up with dependent set. I think in the back of the book they have some strange ways to solve this, but I'm perfectly fine if on the test you tell me you can understand the difference between a dependent set and an inconsistent set. Okay, inconsistent, 0 equals 4. That's a false statement. But 0 equals 0, well, that's a true statement, but it doesn't, it basically you've got two equations that are lines on top of each other. Okay. Now, the last thing that I think I would like to do, yeah, for today is okay, I want to introduce to you what we call Gauss. I wonder, I'm going to flip my paper over here. We're going to call this Gauss-Jordan elimination. It's also called reduced Row-Echelon form. Okay, those are the same thing. Okay, the idea with Gauss-Jordan elimination or reduced Row-Echelon form is basically you have ones on the diagonals and then zeros everywhere else. Okay. Now I know this is a lot of work, and then if this represented 1, 2, and 3, the nice thing about a solution set like this is you could say z equals 3, y equals 2, and x equals 1. Correct? Does everybody understand that? Okay. Now it's a lot of work to do this. Okay. And we're going to spend the rest, hopefully the rest, we got 8 minutes left in class here. We're going to do this. Some students say, this is too hard. I'm just going to get it to row echelon form because that's easier. The problem is when we get into another method here, if you don't know how to put it in reduced row echelon form, it's going to make this other method when we talk about inverse matrices very difficult. So I would like you to master this. Okay, but basically this is what we call here this box. Okay, ones on the diagonals, zeros everywhere else. That's reduced row echelon form, or it's also called Gauss-Jordan elimination. And I know it's a lot of work, but your solution set becomes super easy once you've done it. And if you don't master this skill, it's going to bite you in the butt later on this week. Okay.
Oh,
so I would like you to get good with this. So let me give you a good example here. This is probably going to take a couple of pieces of paper. So let's start with this. I've got 4x plus 8y minus 4z equals 4. And I've got 3x plus 8y plus 5z equals negative 11. And I've got negative 2x plus y plus 12z equals negative 17. Okay. Now remember, my goal here is I want ones on the diagonals. I don't have any ones here in the first column, correct?
Yep.
But I do see, hopefully everybody sees here, row 1 are all multiples of 4, correct?
Yeah.
So if I divided row 1 by 4, I would have a 1x here, and I wouldn't have any fractions. Okay? So if I'm going to do that, that's going to give me 1, 2, negative 1, and 1. Does that make sense? Okay. Now the idea here is I want to get 0. So when you're doing reduced row echelon form, here's what I want to say. Okay. Your goal is you're gonna try to get a 1 in the first spot, and then you work in columns. So you're gonna go down this way. So you're gonna use once you have this 1 here, you're gonna use that and you're gonna work down. Your next step is you're gonna want to put a 1 in the middle spot, and then you're gonna want to get zeros both of these places, and so you'll work with the middle row up and down. And then your last step is you're going to want to get a 1 here and then you're going to want to work up and get a 0 and a 0 here. And then this will be your solution set. Okay? So that's basically, this is the way, and you want to work it this way because if you pick another row that doesn't have a 1 in it, you're going to mess up a previous row that you had fixed. Okay?
Wow.
So the idea here is I'm going to use this row, and I need to turn this 3 into a 0, and I need to turn that -2 also into a 0. Okay? So using this row, how can I turn that 3 into a 0? You see, if I multiplied this by -3 and then I added it to row 2, that's going to turn, so -3 plus 3 is going to be 0. Do you see that? Oh, sorry, I'm off the screen, aren't I?
Yeah.
Okay, so I'm going to take -3 times row 1 plus row 2. I'm going to put the result in row 2. Okay, so -3 plus 3 is 0. -6 plus 8 is 2. +3 plus 5 is 8. And -3 minus 11 is -14. Does that make sense?
Yep.
Okay. Now I need to turn this into a 0 as well. So I'm going to say, if I multiply the top row by 2, that's going to give me a 2 minus a 2, that's going to be a 0. So I'm going to take 2 times row 1, I'm going to add that to row 3, and I want to put the result in row 3. Okay? So this is going to be 2 minus 2 is 0. 4 plus 1 is 5. This is going to be -2 plus 12 is 10. And then this is going to be 2 minus 17 is -15. Okay? Now my goal is I need to turn this 2 into a 1. What's the easiest way to do that? I'm going to divide by 2. Okay? So I'm going to rewrite my top row. Okay? If I've got enough room here. 1, 2, -1, 1. Top row is unchanged. I'm going to divide by 2. So 0 divided by 2 is still 0. 2 divided by 2 is 2. 8 divided by 2 is 4. Sorry, 2 divided by 2 is 1. 8 divided by 2 is 4. And -14 divided by 2 is -7. Okay? Now, the idea here is, so I've got a 1 here, and I need to turn this into a 0, and I need to turn that 2 into a 0 eventually. Okay? So now I'm using row 2. So the easiest way to turn this 5 into a 0 is to multiply by -5 times row 2 plus row 3. I'm going to put the result in row 3. Does that make sense? Okay. So this is going to give me, here I'm going to write the result here. Okay. My middle row is not going to change. 0, 1, 4, and -7. Okay. Now I'm taking -5. So 0 plus 0 is 0. -5 plus 5 is 0. -20 plus 10 is -10. And -5 times 7 is +35. Minus 15 is 20. Okay? Now, it's really easy. I'm going to divide this by -10. Okay, so my bottom row is going to be 0, 0, 1, and -2. Okay. Now, I've got to turn this 2 here into a 0. The easiest way to do that is if I take -2 times row 2 plus row 1, and if I put that in row 1, okay? So now I've got a -2 out here instead of a 5. So 0 and 1 is 1. -2 plus 2 is 0. -8 minus 1 is -9. And +14 plus 1, +14 plus 1 is 15. Okay? All right. So now, gosh, we're running out of time, aren't we? I'm going to try to finish this up quickly. Okay? So now I'm going to use this as kind of my anchor row. I've got to turn this 4 and this -9 to 0. So you can see here I've got reduced row echelon form in the first 2 columns. I've just got to get this 3rd column I'm working on. Okay? The easiest thing to do that is to multiply by -4. So this becomes -4 times row 3 plus row 2. I'm going to put the result in row 2. Okay? Now I know this is hard to see. We're running out of time here. Let me put this here. I'll put this here so I can see it. Okay, so I'm going to rewrite my bottom row here. Actually, I'll rewrite this so you guys can see. So what I had was 1, 0, -9, 15, 0, 1, 4, -7, and 0, 0, 1, -2. Okay, so I just rewrote what I had on the other piece of paper. Okay, so now I'm going to take, if I put it multiplied by -4, -4 times row 3 plus row 2, I'm going to put the result in row 2. So this becomes, so the bottom row is not going to change. Okay, 0, 1, 0, 1, -2. Now we're going to go 0 and 0 is 0. 0 and 1 is 1. -4 and 4 is 0. +8 minus 7 is 1. Okay? Now I need to do the same thing. I need to turn this -9 into a 0. The easiest way to do that is to multiply by +9. So 9 times row 3 plus row 1. I'm going to put the result in row 1. Okay? So 0 and 1 is 1. 0 and 0 is 0. 9 minus 9 is 0. 9 times -2 is -18 plus 15 is -3. Okay? So I'm done. I've got this in reduced row echelon form. And now it's really easy to see the answers. I've got z equals -2, y equals 1, and x equals -3. This is my solution set here. Oh, I didn't mean to cross it out. Okay? So that's what we call Gauss-Jordan elimination. Okay? All right, I know we're out of time, so I'll let you guys go, but I will get a quiz ready for this. One of the difficult things about this quiz, I'm going to rely on multiple choice. However, let me just say that on the test, if I ask for Gauss-Jordan elimination, you're going to have to show me because I don't do multiple choice tests, okay? If I ask for reduced row echelon form, you'll have to show me. And so make sure you know all these methods because on the test, I'm going to be checking methods. On the quizzes, I can't really check because I'm not going to see your work. But just make sure that you're familiar with these. So any last questions before I let you go?
No, I don't have
Okay.
any questions.
Hey, Professor.
All right. Yes.
So there were a lot of us that relied on the math lab that is no longer open. What kind of study helps or study tips would you recommend in replacement?
That's a good question. So you, I will try to check my email this afternoon. One thing I will say, I do teach this class again at noon, and I will be going over the same examples that I just showed you. So if you guys want to show up at noon, it's going to be in the exact same room. This is going to be our meeting room every day. So I don't know if you want to bookmark that thing or just go to the announcements and click on that link. So you're welcome to see it again at noon. If you have questions, email me. I'll try to answer via email, or we could also jump into this room if you're really stuck, and I can try to help you one-on-one. So if you really want to get a hold of me, text me. You guys have my number here? I'll write it down here really quick. 801-809-5916. You can text me and we can try to jump in this room. Sorry, that's a 1. And I'll try to help you out. So I don't know. You might be worth calling the Math Lab to see if they do online tutoring. I know BYU Idaho does, but I think you have to be a BYU Idaho student.
I think the Math Lab is going online.
Okay.
So they
That
have,
sounds.
yes, they have online tutoring.
Oh, I'm glad to hear that.
Nice.
Call the Math Lab and find out how that works, because I don't know.
Thank you.
Okay. All right. So quiz 6.1 tomorrow. It's going to be on chapter 6.1. I won't see your method. I'm just going to trust that you got it right. Okay.
Okay.
So it'll be honor system, but I will know come test day if you know what you're doing. So, you know, if you get through the quizzes, it's going to bite you when it comes test time if you're not doing this. Okay.
All right.
Okay. Well, we will see you all tomorrow at 9 a.m.
All right.
Have a good one.
You too. Thanks.
Mhm.
Bye, guys.
Bye.
Thanks.
Take care.
Squall.